Welcome, everybody. We are going to be doing a Nitro deep dive today. So, an overview and kind of an update on what the Nitro team has been doing roughly since Nitro launched, which was in August. A lot's happened since then, it turns out, including a lot with Nitro. We are or slash will be joined soon by three members of the core Nitro team. We've got Lee and Rachel, aka the Arbitrum Power couple, as well as Tsahee, who hopefully will be connected soon. Maybe we can start with just some more proper intros, actually. You want to just give an intro, Rachel, of yourself and what you work on?
Yeah, I'm helping Lee get set
Oh,
up
okay.
too. But I guess as an intro, hi, I'm Rachel. I work at Arbitrum, or rather Offchain Labs
That's
now,
right.
and I'm a tech lead for this project we're doing called Stylus that we're going to jump into later. I'm also on the Security Council, and I'm really looking forward to the conversation we're going to have today.
Wonderful. Once the other two are set up, we'll get to intros there. But I guess just to set things up here, so stuff that is Nitro's this broad tech stack, and there's been a lot of work done and a lot of progress even since it's launched. Some stuff that we want to be talking about, as Rachel said, she's leading Stylus. We'll talk about what that is. We'll talk about various ways that the Nitro team's moving the decentralization roadmap forward. So this includes validation resources. This includes thinking about a new challenge protocol, which we'll get into a bit, how the sequencer will change over time, things along those lines. And maybe some other little fun things that have happened involving certain mainnet chains that some might not even consider mainnet chains, to give a really cryptic tease. Let's see, is Lee connected? No. Okay, why don't we just, while they're scrambling to get connected there, hopefully, Rachel, you have enough free mental bandwidth in not helping Lee to maybe get us started. Or actually, even before we get to stylus stuff, let's just start with general background. So I've probably already said.
Or I guess Daniel here. I'll let Lee introduce himself. I'm just speaker now on my phone.
Hey, yeah, so this is Lee. Yeah, unfortunately my phone isn't connecting, so I'll just be talking through Rachel's phone for the time being. But yeah, I'm the tech lead for the Nitro team at Offchain Labs, and we've been developing the Nitro upgrade, which we're going to be talking about today, and are currently working on maintaining it and improving it in various ways, which we will also be talking about. So fun stuff.
Wonderful. That was Lee speaking through Rachel. Hopefully I see it's connecting now. Hopefully that works. But in the meantime, just for a bit of background, for those who maybe aren't familiar. Oh, I see a request from Tsahee. Hopefully that works too. I see Tsahee can now speak / connecting. So let me give that a second and he can intro. Has a Twitter space ever just worked? Ever? I don't think I've ever heard one where just everything went right and it started on time. Wait a second. While he's connecting. So if you're not exactly familiar, if perhaps I've said a lot of terms already that sound like made up words. So let's give a little background here. So Nitro, as Leo was saying here, this is an upgrade to the Arbitrum stack that happened in August. And we can start by just giving a general description of Arbitrum and the Arbitrum protocol. Then I'll maybe hand it over to Lee to specify what the Nitro upgrade was. Broadly speaking, very broadly speaking, when we talk about Arbitrum, if you're new to this stuff, Arbitrum is a blockchain protocol, EVM, Ethereum compatible, very similar to Ethereum and how it works. There's transactions, there's smart contracts, things like that. But it runs as a layer 2, which in this context basically means the actual execution of all of the sort of work of running these smart contracts doesn't happen on Ethereum. It happens in this other environment, the second layer. And we only go back and do work on Ethereum if we need to prove that something invalid happens. We have this fraud-proof system. And I would say the fraud-proof system is this kind of interactive game that an honest party can prove that a party is being dishonest. And I would say that's the root of the Arbitrum protocol, this ability to prove fraud back on layer 1. Hopefully, we're happy with that as a very general definition. So Lee, maybe speaking through Rachel's mic, maybe you can give sort of the brief summary of the difference between sort of the old Arbitrum Classic stack and the latest and greatest Nitro stack.
For sure. So with Arbitrum Classic, we were able to prove the Arbitrum virtual machine, which was still a really impressive breakthrough. And for those of you who don't know, the Arbitrum virtual machine actually started as a project for Princeton, I think, way back in, what was it, like way long ago.
Yeah, maybe in 2015, maybe even earlier, if I remember.
Yeah, so the Arbitrum virtual machine as a concept has actually been worked on for quite a while. But with the release of Arbitrum 1, we built the first working fraud proofs for a layer 2 Ethereum virtual machine. And this was obviously a huge breakthrough, right? But we did it with the Arbitrum virtual machine. And this had a couple of trade-offs. One is that We simply didn't have we'd been worrying about how do we prove fraud over this virtual machine. And that had been our number one focus because obviously that's the core of what a layer 2 is. But what we hadn't been thinking as much about is how do we make this virtual machine as fast as possible, right? So that was one thing, was speed. And the other thing was just nobody else was using this. It's called the Arbitrum virtual machine because we were the ones who made it. But what that means is instead of relying on industry standard libraries and such, we had to make our own programs for it. And Rachel actually led the the mini compiler team, which is how we made those programs. But we needed all of this custom effort to make these programs such as ArboS, which ran the Ethereum virtual machine. So the core of Arbitrum Nitro is instead of proving the Arbitrum virtual machine, we're now able to prove a standardized virtual machine called WebAssembly. And this is a very standard virtual machine that's industry-wide, and it's built for the web browser.
Oh, do we lose you? Or Rachel got muted?
Sorry.
Something. We're back. Yep, go on.
Yeah, sorry. So I'm sorry, where exactly did I leave off?
You just got to WASM, or to WebAssembly. So instead, at the lower level now, we can implement.
Yeah, so WebAssembly is an industry standard that runs in the browser, and it's designed to be very secure and performant. So those are obviously two critical properties for Arbitrum. But in addition to not just being secure and performant, it's also standard. And why that's important is we can take existing Ethereum tooling, such as Go Ethereum, and compile it into WebAssembly. So whereas before we had to write our own programs for the Arbitrum virtual machine, now we can build on the shoulders of giants, so to speak, and take the existing trusted and well-known Go Ethereum, compile it to WebAssembly, and then prove fraud over it at layer 2. So that's the core of what Arbitrum Nitro is. It's going from our own virtual machine that was special built for this, the Arbitrum virtual machine, to an industry standard called WebAssembly, which is more performant and also lets us use industry standard libraries and such.
Yes, beautiful. So it's both, there's all sorts of benefits. And at the sort of lowest level, which is where the kind of the fraud-proof game takes place, we use WASM as opposed to this Arbitrum virtual machine, WASM being a standard that we can work with and even maybe do more things with, as we'll get to in a second. At the sort of higher level, in terms of what's running, we can just run pre-existing Go code, namely Ethereum GEF. So that also, we can reuse pre-existing code and just modify it for how it needs to be modified for an L2. So this is very nice for all sorts of reasons. The ones Lee mentioned, also from the perspective of like application developers, this is in a much easier and more direct way, you get Ethereum compatibility. So even the slight divergences from before go away. So Nitro is great. It's really cool. And that was a great summary. Before we go on, now that, I think we might have Tsahee. I thought we did. Maybe now we don't. I see requests. I'm just going to keep accepting requests. And one day we'll have Tsahee. Wait, no, we don't. Okay. As soon as we can, we'll do an intro for Tsahee. I'm also, just by the way, as one correction I got, I believe the AVM was initially developed in 2014. I'm told by Masa. Yeah, it's been around for a while. But yes, this new Nitro stack does very similar things, but essentially does them a lot better and does them with more standardized systems that we can reuse. So let's get to some of the stuff that this lets us do. The first thing was, hey, we have an Ethereum compatible layer 2 blockchain, and that's great. That's been working great, but we can evolve it from there and add new features. So this is where we get to Stylus. Now, there's a lot we could talk about here. There's a lot of angles because this is a kind of far-reaching thing. But Rachel, do you want to just start by giving maybe a brief intro to what Stylus is and what it means for developers, or what it will mean for developers?
Yeah, absolutely. So Stylus is something that's coming out this year. It's a technology that we're currently building, but that will be mainnet ready and everything before 2023 is over. What it does is it allows users to deploy smart contracts written in languages besides Solidity and Viper, these other EVM-specific ones. So soon users will be able to deploy smart contracts written in Rust or C++, and other Web 2 or more traditional programming languages. And so there's a lot there, but from a high-level overview, what it means is broadening the ways in which people can write blockchain technologies on Arbitrum. So maybe you're a game developer and you write in C+. You'd be able to go take your C++ protocol and deploy that to Arbitrum 1 or Arbitrum Nova without having to learn a new language like Solidity. And all of this stuff is, of course, fully interoperable. So if someone's writing a piece of Solidity code, they can have that go call a Rust smart contract, which may in turn call the C smart contract, and so on and so forth, where everything just works, TM.
Yeah.
Yeah, it's a very ambitious thing that we're trying to do, but we are going to deliver it this year. And it has a number of really great properties. One being, as we talked about a second ago, it lowers the barrier to entry into Web3. So if somebody's like in Web2 in a traditional programming job and they want to make the jump to blockchain, they don't have to learn all these new technologies. They can just take their Rust code and use it on chain. But the other thing that's great about it is it adds an order of magnitude more capacity in that computations are over 10 times faster on Stylus. So if you write a Rust smart contract to, say, do some novel piece of cryptography, it can actually execute it very efficiently. Like, as an example, I took a program called Ketchak. This is a very standard hash function, and it's everywhere in Ethereum. But there's actually a precompile on Ethereum that lets you call the Ketchak hash function. It's not really precompile, it's an opcode, but the point is there is a accelerated mechanism for doing cat. If you didn't have that, as is the case with most cryptography, you would have to go implement that in Solidity currently. So what I did is I took a Solidity implementation of Ketchak and a Rust implementation of it. So not using any fancy opcodes, just purely written in these two languages. And I found that the Rust one was over 70 times faster. So that's really exciting. It means that all sorts of high compute technologies are about to be possible on Arbitrum 1 and Nova using this new Stylus WASM virtual machine.
Very cool.
So that's kind of an overview. Does that?
Yes, good stuff in there. We're gonna unpack some of that. Before we go further, though, I think we finally have Tsahee on the mic. So Tsahee, if you want to just give intro who you are, what you do, or do we? It's telling me speaker. Okay, he's labeled as speaker, but is unable to speak. Alas. Okay, maybe let's also take this chance before we go further. I should just clarify that I work, at Offchain Labs, no, not at Arbitrum. I do blockchain development and other sorts of related engineer, blockchain meaning like Solidity level and things like that, as well as technical content and stuff. I am not on the Nitro team. I'm just a fan, so I'm here in that capacity. Maybe as you were discussing to someone like me who writes stuff in Solidity and is used to working at the application level, what you're telling me is that Stylus will mean we can do smart contract work in other languages that aren't Solidity. So let's maybe to unpack that a little bit. If we, as a Solidity developer, I know that I can write Solidity. This will get compiled down into EVM bytecode, and the EVM understands that and knows how to execute it. So if I have a Rust-based smart contract language, what is the sort of, how does this ultimately get executed? How can this work? What does it get compiled down to is maybe one way to start.
That's a great question, Daniel.
Thank you.
So Stylus is built on top of the same WASM fraud proving technology that has undergirded the entire Nitro stack. So recall, in the Nitro model, we're able to prove fraud over WASM. This takes that a step further to where we're able to take contracts written in Rust, C++, etc., compile them to WASM, and then execute those natively. So you take your WASM and you execute that with a fast virtual, and like you do with EVM bytecode, except because it's WASM, it's a lot faster. But what's really cool is beyond that virtual machine, or I guess to add some clarity there, now there's actually two virtual machines that will be in the Arbitrum stack. So you'll have the Ethereum virtual machine for handling computations done in EVM bytecode. So if I write a Solidity contract and it calls out to something that's non-Solidity, for the Solidity part, we'll use the EVM to actually run, and then later we'll prove over that part of the computation. But when you actually enter Rust execution, you switch to a WASM virtual machine. So it's actually a tool VM approach, or a dual VM approach, where there's two different virtual machines working together. And I guess one last technical detail on that, both virtual machines are updating the same state trie. So what that means is, although they're both different runtimes, the EVM and the WASM VM, they both are editing the same database, which means storage and contract calls and all of that stuff works as you would expect. Everything's fully interoperable. There's no separation where a Rust contract has to care about the language implementation of another contract and vice versa. Does that help answer the question?
Yeah, it does. And just to zero in on that last thing. So for, let's say, Solidity, for Solidity developers, for developers who remain writing code in Solidity, or for us that are already deployed in Solidity, to what extent does the way that these contracts, these pre-existing contracts, or these pre-existing thought models, mental models of writing code in Solidity, does this change with Stylus? Are there new things that developers need to know if they're not interested in writing in Rust, or can they just keep moving forward with their Solidity knowledge?
Everything that you can do in Solidity, you'll be able to do exactly as before. So we're still using the EVM. We haven't gotten rid of it. Everything we're doing is additive. So if you're a Solidity developer and you say, I know how to do Solidity, I'm totally good, you can just keep using it and you'll get exactly the same experience on L2 as you would get on L1 is the case today. There's no breaking changes that are coming with this from the Solidity developer's perspective. Now, that doesn't mean you don't have the ability to interface with the wider ecosystem that may start including other languages. So if you're a DEX or something and you wanted to call out to some REST program that maybe implements an efficient order book or something, I'm just throwing ideas out here, then you would be able to go call those libraries as if you were calling another Solidity program and get back results just with the only real difference being the fees will be low. So for the Solidity developer, everything's as it was before. You're just going to find that over time, the libraries and things that you're interacting with cost lower and lower amounts, which is pretty exciting.
So if there's any surprise, the only sort of surprise would be that certain operations will be cheaper than they otherwise would be, but it's not as though we can do something unexpected, which will, probably something to be aware of.
And I say, yeah, and when I say interoperable, I mean it. You could have a Rust ERC20 that you go trade on some exchange or what have you. The possibilities really are open here.
Very cool. And then one other thing, this is where I don't have to feign ignorance, I'm actually ignorant. You can help me understand. In terms of things like gas metering, am I correct in understanding that for this to work, gas is metered at the WASM level with Stylus? Or do these...
That's an excellent question.
Thanks again.
So yes, in the same way one pays for gas, each EVM opcode, at various points in WASM execution, you have to pay for WASM gas, which is surfaced to you, but you just buy EVM gas as normal, and then it converts to WASM gas. From the perspective of the vast majority of people, this is exactly the process you expect. It's just you go buy some gas, you run your computation, but instead of buying EVM opcodes with that computation, you're buying WASM opcodes. So you might go buy a WASM add or a WASM multiply instead of an EVM add or an EVM multiply. Now, what's really cool is because WASM is so fast, each opcode is way cheaper. So I found that an add in WASM is over 1,000 times faster than an add in the EVM. And so what that means then is the gas price associated, or not gas price, but the gas cost associated with doing an add is therefore much smaller in the WASM model. So there's two notions of gas, but ultimately they can be freely exchanged for one another. And I guess to explain too, why are there two notions of gas? Because WASM is so much faster. We have to break each EVM gas up into many little pieces of a gas. Right now, like 10,000ths of a gas. An add or a subtract or something is so quick that even just assigning one EVM gas would be way too much. It would be way too expensive, considering the amount of actual wall clock time that a given computation really entails. Does that all make sense?
That all makes sense. Very cool. And let's maybe popping up that stack a bit back to what you started talking about, which is ultimately these support of new languages. Without giving dates or anything like that, what language do we expect to be targeting first in terms of introducing a language that developers can use to make smart contracts?
The primary focus, so the thing we're delivering this year and trying to add really nice libraries for that users will be able to depend on, are Rust and C. And by supporting C, we also get C++. So those are the three to really be thinking about. And if you just take a survey over a lot of the different, if you look at all L1 technologies, they often use something like Rust or C. And those kinds of things will now be possible on Arbitrum chains. So those are our main ones, but it is an open model, and there's nothing that really ties it into Rust or C specifically. So if one wanted to take Move I just give that as an example, not that something we're personally delivering right now. If one wanted to take Move and compile it to WASM, they would find that with not a very high lift, they'd be able to start executing programs on Arbitrum. So we'll add more languages over time, and I imagine people in the community will want to too. But our kind of first class support, the thing that we're really wanting to deliver is Rust and C and C++.
But as you say, in principle, essentially, correct me if I'm wrong, but in principle, this architecture could be extended to cover any language that can be compiled to WASM. Is that basically correct?
So there are a couple of pieces of nuance. If the language has a really large runtime, although it is possible to come up with models to run them, it's not something we would want to immediately focus on. So for example, like running Go, you would probably need to use something like TinyGo, so a non-standard compiler, to avoid having this huge runtime. Like for example, I took the Hello World program in Go and compiled it to WASM, and I found it's over 700,000 WASM opcodes, which is quite dramatic and means that if you're deploying these things and you want it to be efficient and cheap and all of that, it just doesn't make sense to really target Go for that reason, in excess of TinyGo, to be clear. So if you've got a large runtime, if there's some huge like Java virtual machine, for example, in the background, that's not really something that we're targeting, though it is conceivable with future work one would be able to do that stuff. But if you just look at what smart contracts are being written in and the really efficient systems programming languages that people are using in Web 2, I think Rust, C, and C++ really does cover the vast majority of the programmer needs.
Cool. Awesome. Okay. I'm learning a lot. This is fun. But let's move on because there's more stuff we want to cover. But yes, very, really cool. Definitely some of the more exciting technical work we're doing. Keep an eye on this, folks. Let's move along to, some of the kind of decentralization related things that have happened and have been done. We'll just keep trying to connect Tsahee. Okay. Tsahee, if you can speak, just start speaking. Just interrupt me at any time. But in the meantime, okay, so obviously we just, as I'm sure most of you are aware, we just announced the sort of new Arbitrum DAO and the Arbitrum governance system. It's very exciting. This happened yesterday. Yes, I'm a bit delirious. Forgive me. And this is an important step in moving things towards decentralization. And actually, I wish I had the link. I would pin it or whatever. But if you look at the governance docs page, we have a page called something like State of Progressive Decentralization that just kind of lays everything out in a very clear way. I'm very happy that we just have that out there. And maybe we can talk about some of those various pieces of what we want to happen, what we hope will happen over time in terms of progressive decentralization, and how those questions intersect with Nitro and what the Nitro team is doing. I guess let's maybe start with the notion of upgradability generally, chain ownership actions, right? So this is very broadly speaking in a governance, in a system like Arbitrum, where there's these chain owner affordances, right? There's essentially this administrator. This can do all sorts of very big, important things, including updating the core contracts. This is the thing that we've given over to the governance system. In terms of Nitro, the sort of subset of this, or the little piece of this that affects the sort of Nitro tech itself, is that the Arbitrum DAO, the governance system, has the ability to update what we call in the code base the WASM root, or I guess the WAVM root. Maybe since Tsahee seems to be in limbo, maybe I'll hand it off to Lee. Can you talk a bit about like this implementation detail and what does it mean for governance to have this power?
Yeah, hey everyone, it's Lee on Rachel's phone again. So one question when you're proving fraud is like, what if two people disagree about what's happening? What if one person says we're executing Geth and the other person says we're executing a Pong game or something, or playing Tetris, right? How do you actually tell what code should be executed? What we do for this is we have what's called a Merkle root of the entire code of Arbitrum, which lives on layer 1. So a Merkle root is a condensed form. It's a single hash that represents all the code that makes up Arbitrum. So all of that Go Ethereum code we compile in, all of the pre-compiles, all of the Brotli decompression, all of that, we take it together, we hash it together, and we produce a single hash, which is called the WASM module root. And this is core to Arbitrum because it's what determines what is running on Arbitrum. It's what you do a fraud proof over, and it's what determines the outcome of every block. And this WASM module root, as Daniel mentioned, we've now handed over to the community, to the DAO. And the DAO now has the power to change this WASM module root, and with it, change the code of Arbitrum. And this is a pretty amazing power because of this, how broad it is, right? In theory, you could change it to run any sort of code. Now, obviously, we've set the Arbitrum constitution, which can be amended, but it sets up various values like being Ethereum aligned. But in theory, you could run any, or the community could decide to run any code on Arbitrum and change the way the system operates. So it's a really powerful capability that the DAO has to change this WASM module root.
Yeah, so it's one of the fundamental pieces of chain ownership, or what it means to be a chain owner, is this. And as you said, this architecture, the way it's built, it's literally a commitment to the code that's going to be executing on layer 2. Is that a fair summary? Like it's a hash.
Yeah, absolutely. Now, people still have to upgrade their nodes to this new version of the
Mhm.
code, but if you're running an outdated node, it'll probably just stop running because it can't interpret the new ArcOS version, is what will usually happen. So it's basically the WASM module root is the source of truth here, right? Like someone could try to claim that a different block is produced or that different code should be executed. But at the end of the day, what it really comes down to is the fraud proofs on layer 1. And what those are determined by is the WASM module root. Yeah, at the end of the day, it's the source of truth for what code makes up the Arbitrum chain.
And you mentioned ArcOS, which is essentially a shorthand for the L2 state machine. Is that
Yeah,
more or less?
ArcOS is an informal term for like the parts of the state machine that we've added from Geth. So like Geth handles the core EVM, but for something like depositing to layer 2, Go Ethereum has no notion of what a deposit is. You don't deposit to Ethereum. So we've had to add in stuff like that to the core state transition function, and we call those sort of extra things that Arbitrum can do ArcOS.
Okay. Gotcha. So ArcOS, we're referring to the new stuff. So it makes up some piece of the state transition function, let's say. And
yeah,
cool. And yeah, so there's a number of important pieces of what it means for governance to control the chain. But as Lee said, this is maybe in some sense one of the most important ones, or among the most important ones, because you can define what an Arbitrum chain means. So yeah, so that is definitely a big step there. In terms of thinking about the other pieces of decentralization, and maybe whoever wants to chime in here, because I was hoping to get to Tsahee. Let's see if there's another request. I don't know. But we can talk about, and this is actually one piece of decentralization that's not listed on the state of decentralization page I mentioned, because it doesn't have to do with what's directly on chain. But the sort of resources required to run a node or to run a validator off-chain is obviously still important. We want it to be, among other considerations, we want it to be as, let's say, accessible and easy as possible in terms of resource requirement to run an Arbitrum node. Can we talk a bit about what sort of work has been done there on the Nitro side, particularly around just-in-time validation? I don't know if Lee, if you're the best to go to for that, or...
Yeah. So, yeah, sorry. We're still trying to get phones connected. Yeah. But yeah, okay, so this was a little bit ago, but one thing that's always important, as you were talking about, is making the ability to validate something available to anyone. And one way users are able to, or validators are able to gain confidence that the code is operating correctly, is to perform a little simulation of a WASM fraud proof. Now, to be more technically accurate, you're able to take the WASM module root that Lee was talking about and execute in WASM the steps needed to produce a block. If everything is correct and the code is accurate and all of that, native execution gets you is exactly what you will get in WASM. So if it was time to fraud proof, you would get the same results. As a safety measure, we've added the ability for a user to choose to just run things in WASM anyways. So even though native execution and WASM should be aligned, if you're about to engage in a fraud-proof process, it's good to be able to just check and say, hey, if I run this through WASM, will I get the same result? That process used to be very slow because it required running through this thing called Arbitrator, which actually provides the fraud proving mechanism for getting to that one-step proof, as it's called. So it will actually execute WAVM opcodes, interpreting them one by one, WAVM being what WASM is ultimately compiled down to and what's posted on chain. It's a little complicated, but that's how it used to work. We came up with a new way of doing things. He's done a lot of work on this in particular, called where we use just-in-time acceleration to dramatically speed up this process. So instead of taking WAVM and executing those instructions one by one, which can take quite a bit, you use a standard off-the-shelf JIT runtime that is able to use what's called just-in-time compilation to really speed up this. And it's like orders of magnitude faster. In fact, we're able to now validate using WASM faster than we are than the current speed limit of the chain. Like I find on my personal computer, even though the chain is running at 7 million gas a second, I could validate at 40 million gas a second. And if you've got more cores, you can validate at increasingly higher numbers. But point being, what used to be a rather expensive, though unnecessary redundancy is now much, much faster. And like over 95% faster, which translates to lower compute costs for running such a node. So the actual cost of being a validator and having all of the assurances one might want has dramatically fallen.
Very cool.
And this just gives confidence and makes it more accessible, because we don't want people to have to go run a really powerful cloud computer that you couldn't possibly have at your home to do anything with Arbitrum like that. That is something we're constantly exploring, lowering those costs. And right now they're quite tractable.
Cool. That was a very good answer. And I did throw a bit of a curveball at you with this question because I know it was a while ago. So very good job. But the I'm assuming it's still, I didn't realize it would be that cheap to execute in WASM. I assume it's still cheaper, or it's still more performant to execute in whatever native Go environment if you're just running a sort of non-validating full node. Yeah.
So just running a node, that's the fastest way to do it. Just running native, which is all anyone needs to do, to be clear. And if the code is completely correct, we believe it is, though there's a bug bounty if you can find a divergence. We'd love to see it. But yeah, if you just run the native code, you should get the correct results, and it'll be much faster. So my computer can locally do 40 million gas a second in WASM, but I haven't tested what it could do in native, but it would definitely be higher. If I had to ballpark it and just guess, what would it be? I'm guessing it would be something like 60 million gas a second, because there tends to be a 50% performance overhead to go do something in WASM. But the point there is it's actually not this massive computational difference. It's really quick. And we've got industry giants like Google and Apple and Microsoft all contributing and depending on this standard. Recall that WASM is the WebAssembly standard. And what that means is anyone who cares about web browsers, which includes some very important players in Web 2, they're going to be contributing resources to developing these runtimes and making things really fast and having these things be accessible and secure and sandboxed and all of that. So by having WASM around, we're getting to just inherit all of that benefit from the broader world. And I think the performance measures just show the fact that we can, my computer's 40 million, maybe someone else's is a bit different, but the fact that we could be talking about tens of millions of gas a second that one can validate, that's really exciting. And it just is a testament to how good WASM is as a standard.
Yeah, and as you say, it's very important that both sides of this are important. As you say, most sort of Arbitrum nodes out there, if you're running a node or using a third-party node, they're not going to be executing at the WASM level, because we can build the Arbitrum state from native Go execution, which is nice because that's more performant. But the other way to execute, you want to execute in WASM if you're a validator who's staked and securing the Arbitrum chain. You want to run in the same mode that you're going to be fraud proving in, as just an additional safety measure. And yes, we also want that to be cheap and performant too, because we want it to be easy to become a validator. So yeah, this is very good and cool. Maybe that. Yeah.
It's certainly nuanced. To be very clear, one needn't run in WASM, right? The average person does not need to do this. It's just an optional safety mechanism that we provide to anyone who might be staked and want to validate, as you're talking about. So we're not just thinking about how do we make running a node easy. We're thinking like, how do we make all aspects of all one might want to do easy? And that includes having these really nice and secure redundancies.
Yes. So maybe that, I'm just looking at the clock. There's a few other things I want to touch on. So maybe we'll speed run through a few cool, exciting Nitro things. But that segues into, so in terms of validators, those who are securing the Arbitrum chain or securing the bridge between Arbitrum and Ethereum, one thing you'll see in terms of state of decentralization is, as of now, the validators are still on a whitelist. The protocol is built so that in principle anybody can become a validator, but at the moment they're currently on a whitelist. And we've started talking about the main reason for that. There's a certain limitation in the current version of the protocol that we think we have a nice solution for, and we want to push that solution out there, push it out for the DAO to look at and pitch it to them. And once that gets accepted, then we can be in a better place to remove the whitelist. But let's talk a bit about that in terms of this limitation. In the current system, there is this, so we have this guarantee that as long as there's one honest validator, we can ensure safety of the system. But one of the things that we can't guarantee is how long it will take for sort of a block on Arbitrum to finalize on Ethereum, which is to say there is an avenue to delay confirmation. There's a certain like annoying attack vector, which maybe I can just talk about that a little bit, and then we'll talk about maybe what comes next a little. But in terms of the delay attack, without going into too much details, we have a blog post that really outlines the delay attack itself. The basic idea here is you can keep starting a challenge, so one of these dispute games, and just continuously lose deliberately. So the idea is you start a challenge, someone has to compete with you, and then, even though an honest party will ultimately win, you can do this many times. And there's a certain way of doing this so that this honest party is just going to have to wait and challenge you only sort of one dispute at a time. There'll be this queue, and knocking a member off of this queue takes a week each time. The specific attack has to do with a dishonest party who makes an honest claim and then loses on purpose. So there's this kind of annoying little loophole. And it's not the worst thing, but what it means is if somebody were to do this, essentially the system confirmation could be delayed, which really only means that withdrawals from Arbitrum to Ethereum could be delayed. It would be a very costly attack, so you have to spend a lot of money to carry this out, but it's possible. And we think we have a solution. So we've been really trying to formalize it and check it as much as we can. And we're working on some implementations of it. But I guess what we can just say, and we'll release those details so the community can understand it, and then hopefully we can move things along. But essentially the idea here is with a different version of this protocol for challenging, you can get an upper bound on how long an entire challenge could possibly take place. So you can put a cap. The tricky thing is you want to be able to do that without there being some sort of annoying denial of service vector. So in other words, okay, it only takes X amount of time before a challenge will be fully resolved, but we don't want it to be such that those who are involved in the challenge have to do so much work that they can't even keep up, and then they end up losing anyway, that kind of thing. So there's this trade-off, but yeah, we have a nice architecture there. And as I say, ultimately, any sort of upgrade like this goes through the DAO. You can look forward to that being released probably fairly soon in terms of more concrete information about it. I have to be a bit vague at the moment. Let's talk about one other piece that's related to decentralization and stuff, which is the sequencer. There's been a lot of sort of interest in this lately. The sequencer is a part of the system that for the most part, determines ordering of transactions on L2. And there's two things we could talk about here. One is a centralized sequencer versus a decentralized one. And then there's this orthogonal consideration, which is something regardless of whether it's centralized or decentralized, what is the heuristic that it actually uses to order transactions? And we recently talked about a potential upgrade that we could do here that we're calling time boost. But maybe to get us started, maybe we can go back to Lee here. I don't see Tsahee on still. Maybe just if we can describe the current state of the sequencer in terms of what is the sequencer's ordering policy. Yeah, let's just start there.
Sure. Yeah, absolutely. So the sequencer's current ordering policy is very straightforward. It's first come, first serve, and that's what it sounds like, right? If I send a transaction before Daniel does, and the sequencer receives my transaction before it receives Daniel's, then it will put my transaction first. But despite this sounding simple, it has a few problems. The big one is that it creates what's known as latency racing. So, for instance, if Daniel and I both see a really profitable opportunity where the price of Ethereum on two different decentralized exchanges is mismatched, we might both really want to be the first one to get a transaction in and take advantage of that opportunity and arbitrage and correct the state of the dexes. But if we're both trying to do that, then it just becomes a question of who can get our transactions to the sequencer first. And this creates a lot of really bad incentives, like trying to send the transaction a ton of times and trying to connect to our sequencer feed a ton of times to get information about this discrepancy first.
Right. In other words, just to step in real quick there, it's not, when we say get it to the sequencer first, this has nothing to do with what we can enforce on chain or in contracts. We're just talking literally send a message on the network level to the sequencer. So this is where, incentives get weird, and things like literally being geolocated physically closer to the sequencer becomes an advantage because messages travel faster. So yeah.
Exactly, which is also bad for decentralization, by the way, because that means that there's an advantage to being in the same geographical place as the sequencer, which kind of centralizes things a bit. Not the end of the world, but yeah. So what we've proposed instead is a mechanism called time boost. So the principle is that now, if Daniel and I both really want to get our transaction in, instead of just trying to get as close to the sequencer as possible and send our message to the sequencer first, we can both bid on how much we want to be the next transaction. And the actual mechanics of this bidding are really complicated, and you can read our blog post on how this exactly will work. But the basic principle is, instead of spending money trying to get servers that are really close to the sequencer and trying to spam it with all these different connections and make all these messages, instead of antisocially trying to latency race, instead we can all come together and bid on the next transaction. It's important to note what this doesn't allow people to do. So this doesn't allow people to front run you, for instance. So right now on Ethereum, if you make a trade to buy a bunch of ETH or something, somebody else can step in first, buy that ETH before you, and then sell it to you at a higher price. That's still not going to be possible on Arbitrum. It's not currently possible, and I think it's a core value of Arbitrum that I hope will be preserved, that it will never be possible.
Yeah.
And we're definitely not changing that with this. The only thing we're changing is what's called backrunning. So if you notice a discrepancy that's open on the market, like for instance the price of Ethereum being different on two different decentralized exchanges, we're talking about who gets to be the person who does that arbitrage and resolves the prices. That's what Time Boost is all about.
Yep. So yeah, you can essentially get an advantage in terms of getting your transaction in front of other transactions within this very small window of time. And there's still a private mempool, so everyone's seeing the same chain, or everyone's seeing what's been published by the sequencer, let's say, in the sequencer feed. And now I can bid to increase, to move my position back versus the other transactions that are competing by this little half-second window or something. So you can, there's the sort of back-running opportunities, but in this very restricted way. And I think this is a nice balance, and should make the various parties, users, MEV searchers, and so on, happy and be able to do what they want to do. And some of our thinking on this was definitely evolved and was changed by discussions with the Flashbots team. So shout out to them. Although I think what we're doing is maybe not quite what they proposed, but it led to us in thinking about this in different ways. And if nothing else, they convinced us that the latency racing thing is a problem we're thinking about seriously and worth having a solution to. Okay, real quick, I realize we only have 2 minutes left, but I'm also remembering that I gave a cryptic teaser at the beginning. So maybe Lee, if you can just talk real quick about the time that fraud proofs were used live on mainnet.
Absolutely. Yeah. So when you might recall during the Ethereum merge, some people forked off into Ethereum proof of work, which is a chain that still uses proof of work to power a fork of Ethereum. And this is an interesting question for Arbitrum, because the Arbitrum smart contracts exist on Ethereum, which meant that they also existed on this fork of Ethereum. So there's actually an instance of Arbitrum 1 and I think Arbitrum Nova, Arbitrum Nova as well, with no sequencer, that are running on the Ethereum proof of work forks. And this is quite interesting, by the way, because its validation is permissionless there, for instance. So what someone actually did is they made a malicious assertion on the Ethereum proof of work Arbitrum chain. And they said, hey, I can't know exactly what they asserted to, but I think it was probably, hey, I have a withdrawal that's going to give me all of the money in the chain. But luckily, I was running a validator that was watching that chain. And my validator saw this malicious assertion, and it created its own assertion that was correct and said, no, actually, that this withdrawal is fake. And this was actually the I think first usage of Arbitrum fraud proofs on a mainnet. And I say a mainnet here because Ethereum proof of work does have real value.
That's right.
And sure enough, 7 days later, I had won the challenge as designed. My validator successfully contested the attacker's assertion, and I got a bit of the Ethereum proof of work stake they put up as a result. Not worth a ton, but still fun.
Yeah, so very cool. We've seen fraud proofs work live on mainnet. The definitions of mainnet, I guess, get tricky now that we have actual testnets that are worth money,
Yeah.
but still was very cool and surprising, but I guess somebody figured they may as well try. But yeah, Lee's on his personal computer proved fraud, so that's pretty neat. Okay, I think we're at about the hour mark. Thank you, folks. I'm sorry Tsahee didn't get to join. Thank you, Lee and Rachel. I asked you pretty difficult, loaded questions. We got pretty in the weeds, and you did a great job of answering. So thank you for humoring us.
Thank you. I enjoyed answering them.
For sure.
Yeah, thanks, Daniel.
For sure. All right. I think we will close it there. Anything to say at the end here? Any shout outs, or are we good? I think we're good.
I guess one little thing. Yeah. We've talked a lot about the things that Offchain Labs is working on, but it's ultimately up to the community to adopt any changes that we might author. So all these things we've talked about, be it the new challenge protocol, be it Stylus, with all that extra programming languages, whatever it may be, it's in the community's hands to decide what the future is. But Offchain Labs will continue to develop technologies that we believe the community will benefit from.
Indeed. Governance, the DAO governance goes live a week from yesterday on Thursday, so 6 days. All the information's available now. And yeah, you can even apply to be a delegate now if you're interested. So do that. Oh, also, like, we're hiring. Yeah, we meaning Offchain Labs. Also that there. I was told to say that. Okay, cool. We're up there. Thanks all.